What if everything you learned about the age of exploration, about who discovered what and when, is fundamentally incomplete? Picture this. You are an archivist in a dusty library, and you unroll a map drawn in the year 1513. The ink is faded, the parchment is brittle, but the coastlines are remarkably clear. Your eyes are drawn to the bottom of the map, to a landmass that should not be there. It shows the northern coastline of Antarctica, a continent that would not be officially discovered by the Western world for another 300 years. And it shows it not as a frozen wasteland, but seemingly free of ice. This is not a scene from a fantasy novel. This is the reality of the Piri Reis Map, a genuine historical document that sits in a museum in Istanbul, and it is a profound mystery that challenges the very foundations of our history. These ancient maps are far more than simple curiosities or artistic interpretations. They are potential evidence, silent witnesses to a world that has been rewritten. They contain traces of geographical knowledge that should have been impossible for the cartographers of their time to possess. We are talking about coastlines that match modern satellite surveys with stunning accuracy, land masses that were supposedly undiscovered, and annotations that speak of places no one should have known about. This is not about a few misplaced rivers or speculative islands. This is about systematic, precise information that directly contradicts the linear narrative of human progress we find in our textbooks. It forces us to ask a staggering question. What if a sophisticated civilization, now lost to time, mapped the entire globe thousands of years before the rise of Greece or Rome? In this video, we are going to embark on a journey to uncover these secrets hidden in plain sight. We will investigate these enigmatic maps, from the infamous Piri Reis to other stunning examples like the Oronteus Finaeus and Buache charts. We will analyze the compelling theories they inspire, theories of advanced ancient seafarers, catastrophic pole shifts, and vast libraries of lost knowledge. We will question what these cartographic contradictions truly mean for our understanding of human history. Are we looking at the fragmented legacy of a forgotten epoch? Prepare to question everything you thought you knew about the past, as we delve into the evidence that suggests our history is deeper, more mysterious, and far more incredible than we have ever been taught. Now, let's step into the shoes of that historian for a moment. Imagine the chill of a quiet archive, the smell of old paper and leather. You're carefully studying a Portolan chart, a navigational map from the 1500s, its lines drawn with painstaking detail. Your finger traces a familiar coastline, but a cold shock runs through you as you realize its identity. This isn't a speculative drawing of a mythical land. It's a clear, recognizable depiction of a continent that, according to every history book on your shelf, would not be stumbled upon by European explorers for centuries. This is the heart of the anomaly. It's not a simple case of a cartographer getting a few miles of coastline wrong. What we are looking at is a systematic contradiction, a piece of information that exists outside of its time, like finding a blueprint for a microchip in a Renaissance workshop. To truly grasp the mystery, we must learn to distinguish between a simple error and a profound anomaly. A mapmaker might miscalculate the curve of a bay or place an island in the wrong spot. These are common mistakes born from imperfect measurements or tall tales from sailors. But an anomaly is something entirely different. It is the precise representation of a landmass that was, by all accepted historical accounts, completely unknown to the culture that produced the map. Think of it this way. If a medieval map of Europe showed England with a roughly correct shape, that's to be expected. But if that same map accurately depicted the entire outline of Australia, complete with the distinctive Gulf of Carpentaria that would be an impossibility that demands an explanation. The significance lies entirely in that precision. A misplaced river is a mistake we can understand. A correctly rendered continent, thousands of miles away and separated by impassable oceans, is a mystery that shakes the foundations of history. This forces us to ask a critical question. Where is the line between artistic license and technical data? When a cartographer draws sea monsters in the ocean or fills empty spaces with illustrations of kings, that is clearly artistic flourish. But when they chart a coastline with mathematical accuracy, when the proportions and angles align with reality in a way that cannot be attributed to luck, we are no longer looking at art. We are looking at what appears to be scientific data. This is the crucial distinction that separates these anomalous maps from other historical curiosities. They aren't just pretty pictures, they contain specific, verifiable geographical information. The coastlines have the correct longitude and latitude, the mountain ranges are in the right places, and the overall shape matches what we can now see with satellite technology. This level of detail suggests the map was copied from a source that was created through actual survey, through someone having been there and possessing the advanced knowledge required to translate a spherical world onto a flat surface. So how could such knowledge have been obtained? This is the question that launches us into the deepest waters of this mystery. The most straightforward explanation, that 15th or 16th century explorers somehow secretly achieved these feats, simply doesn't hold up under scrutiny. The technology for such precise global mapping, particularly determining longitude accurately, did not exist at the time. This leaves us with a far more staggering possibility. The information must be older, much older. It hints at the existence of a sophisticated seafaring civilization, lost to the sands of time, that possessed navigational and cartographic skills rivaling our own. These maps, then, are not the originals but faded photocopies of a much older document, a surviving fragment of a world map from a forgotten age, carefully preserved and passed down through generations of copyists who may not have even understood the full significance of what they were duplicating. This sets the stage for our investigation, pointing toward a hidden history waiting to be deciphered, one coastline at a time. Now, let us focus our attention on one of the most famous and controversial documents in this entire mystery, the world map drawn by the Ottoman admiral and cartographer Piri Reis in the year 1513. Imagine him in his study in Constantinople, surrounded by scrolls and charts captured from Spanish and Portuguese vessels, or perhaps traded from Arab scholars. He was not claiming to have explored the world himself. Instead, he was a compiler, a scholar piecing together a global picture from a library of source maps, some of which he explicitly stated dated back to the time of Alexander the Great, centuries before the Common Era. The result was a map that was both a product of its time and an artifact utterly out of time, because tucked away in its lower section is a depiction that has baffled historians for decades. It shows a landmass that bears a striking resemblance to the northern coastline of Queen Maud Land in Antarctica, a continent that would remain unknown to the Western world for over 300 more years. The immediate and most common rebuttal from skeptics is that this land is simply a distorted representation of South America. It is true that the map also shows parts of South America, and the two continents can appear vaguely similar. However, this explanation begins to fray when we look closer at the details. The Piri Reis map does not just show a rough, blob-like shape. It depicts specific coastal features, bays, and peninsulas that align remarkably well with what we now know lies beneath the Antarctic ice sheet. In the 1940s and 50s, seismic surveys and later satellite radar began to map the subglacial topography of Antarctica, revealing the true shape of the continent buried under miles of ice. When researchers like Captain Arlington Mallory and Professor Charles Hapgood compared these modern geophysical profiles to the Piri Reis outline, they found correlations that are difficult to dismiss as mere coincidence. The map appears to show the coastline not as it is today, a frozen rim, but as it would be if the ice were gone, a coastline that has not been visible since a period of intense global warming thousands of years ago. This leads to the extraordinary theory that the source maps used by Piri Reis were themselves copies of much older surveys, created by a culture that navigated the seas when Antarctica's northern shores were temperate and ice-free. Scientists estimate that the last time such conditions existed was during a geological warm period that ended roughly 6,000 years ago, or perhaps even earlier. So we are faced with a staggering implication. If this interpretation is correct, it means that a sophisticated seafaring civilization existed in deep antiquity, possessing not only the shipbuilding technology to undertake a voyage to the southern polar region, but also the advanced mathematical and cartographic knowledge to accurately chart their discoveries. This single document, a fragile piece of parchment from the Ottoman court, challenges the very core of our historical narrative. It suggests that the great age of exploration by Europeans was not a pioneering first, but rather a rediscovery, a retracing of routes mapped millennia before. The true power of the Piri Reis map lies in this challenge to linear progression. Our standard view of history is one of steady, upward advancement, from primitive tools to complex societies, from coastal hopping to transoceanic voyages. But this map hints at a cyclical model where knowledge is gained, lost in some cataclysm, and then slowly regained. What could have caused such a loss? The answer might be tied to the very reason Antarctica became ice-covered again: a rapid shift in climate, or even a more dramatic geological event. The civilization that mapped a green Antarctica would have been vulnerable to the ensuing global changes, potentially vanishing beneath the waves or collapsing into a dark age, their great achievements reduced to fragments copied by later cultures. The Piri Reis map, therefore, is more than a cartographic oddity. It is a potential relic from a forgotten epoch, a ghostly imprint of a world that was rewritten by time and ice, waiting for us to decipher its icy secret. Now, let us transport ourselves from the Ottoman court to the library of a Renaissance scholar, perhaps in Paris or Rome, nearly 2 decades after Piri Reis put ink to parchment. The year is 1531, and the French cartographer Oronteus Finaeus is presenting his own masterpiece, a cordiform or heart-shaped world map. Where the Piri Reis map offered a tantalizing but fragmented glimpse of the South, the Oronteus Finaeus map presents a revelation. It doesn't just hint at a southern continent, it depicts Antarctica in stunning, almost comprehensive detail. This is not a rough sketch. You can clearly see a landmass roughly where Antarctica sits today, but it is portrayed with a level of geographical information that should have been utterly impossible for any European of the 16th century. The coastlines are intricately detailed, and the interior is filled with what appear to be rivers flowing from mountainous regions into the sea, and at its center, a distinct, large depression. This is where the mystery deepens exponentially. When modern cartographers and historians like Charles Hapgood overlaid the Oronteus Finaeus map with modern seismic maps of the subglacial Antarctic bedrock, the correlations were nothing short of astonishing. The rivers on the map align almost perfectly with the paths of subglacial waterways we know today. The mountain ranges correspond to known subterranean peaks. Most strikingly, that central depression on the Finaeus map aligns with the location of the vast subglacial basins that lie beneath the ice sheets of East Antarctica. This is not surface ice we're talking about. This is the actual shape of the continent itself, buried under thousands of feet of ice. The map seems to be showing Antarctica not as it appeared in 1531, but as it would appear if all the ice were miraculously stripped away. This presents a chronological problem of monumental proportions. For Antarctica to have been ice-free, with flowing rivers and a temperate interior, we have to look back not thousands but millions of years. Geological evidence suggests the continent has been covered in its present ice sheet for at least 6 million years, with the last period of significant warmth occurring even further back in deep time. So how can we explain a Renaissance scholar having access to such information? The idea that Oronteus Finaeus or any of his contemporaries could have guessed this topography with such accuracy is statistically negligible. It defies belief. This level of precision points overwhelmingly to a single, inescapable conclusion. Finaeus was working from a source map of incredible antiquity and even more incredible precision. The implication is that someone, a very long time ago, surveyed the continent of Antarctica when it was free of ice. This unknown civilization would have needed not just ships capable of reaching the polar region, but a sophisticated understanding of spherical trigonometry to project the curved surface of the Earth onto a flat map with such fidelity. They would have required advanced instruments for navigation and surveying, techniques that would not be reinvented in Europe for centuries. The Oronteus Finaeus map, therefore, is not merely a map. It is a ghost image, a photographic negative of a lost world, preserved through countless copies and translations until it finally found its way onto the desk of a 16th century scholar who likely had no true understanding of the revolutionary data he was reproducing. It pushes the boundaries of conventional history far beyond the classical world, pointing towards a prehistoric era of human or human-like achievement that we are only just beginning to comprehend. Moving forward another 2 centuries, we encounter a map that seems to confirm the astonishing implications of its predecessors. Picture the scene in 1737 at the French Academy of Sciences. The respected geographer Philippe Buache, known for his meticulous and scientific approach, presents a new world map. It is not a fanciful creation. It is a carefully reasoned geographical theory rendered in ink. And it is utterly revolutionary. Buache's map depicts the southern polar region not as a single, solid landmass, but as 2 distinct, large continents separated by a vast body of water he labeled the Mer Glacial, the glacial sea. For his time, this was considered a speculative, even erroneous hypothesis. After all, no explorer had ever seen such a thing. Yet, this is precisely what makes the Buache map so profoundly compelling when viewed through a modern lens. The true shockwave comes when we compare Buache's 18th century depiction with what we now know from 20th century technology. Using ice-penetrating radar and seismic surveys, scientists have mapped the actual bedrock of Antarctica, the continent's true skeleton hidden beneath ice that is miles thick in places. What these modern surveys reveal is astounding. Antarctica is not, in fact, a single monolithic continent. It is an archipelago of large landmasses, primarily East Antarctica and West Antarctica, separated by a deep subglacial trough that runs from the Weddell Sea to the Ross Sea. This trough, filled with ice, is essentially a frozen sea separating 2 major land formations. The correlation with Buache's 2 continents and his Mer Glacial is uncanny. How could a geographer in the 1700s have possibly deduced the subglacial topography of a continent that was nothing more than a frozen, unexplored mystery to his contemporaries? The explanation becomes even more intriguing when we examine Buache's own claims about his sources. He did not base his map on new reports from daring explorers. The interior of Antarctica would remain a complete mystery for over 100 more years. Instead, Buache stated that he was synthesizing his map from much older source materials, including maps that dated back to ancient Greek and Phoenician explorations. He was, in a sense, a historical detective, piecing together fragments of ancient geographical knowledge that had been preserved, copied, and passed down through libraries and scholarly traditions over countless generations. He took these ancient claims seriously and gave them a form based on the scientific reasoning of his day. This means the information about Antarctica's split nature did not originate with Buache. He was merely the latest link in a very long chain of cartographic transmission. This concept of a preserved knowledge chain is central to the mystery. It suggests that the original survey of an ice-free Antarctica, showing its true geographical form with seas and separate landmasses, was conducted in the distant past, perhaps during a warm interglacial period. That incredibly ancient map, or more likely a series of maps, was then copied and recopied by successive cultures, maybe the Minoans, the Phoenicians, the Greeks, the Arabs, and finally medieval European scholars. With each copying, the context was lost, but the core geographical data, the shape of the land, was faithfully preserved. By the time it reached Buache, the map was a ghost, a relic stripped of its original meaning, yet still containing a startlingly accurate geographical truth. He interpreted this data through his own scientific framework, producing a map that was ridiculed in his time, but now appears as a stunningly accurate echo of a world that existed before the ice claimed it. The Buache map, therefore, adds a critical layer of credibility to the entire enigma. It is not an isolated anomaly. It forms a consistent pattern with the Piri Reis and Oronteus Finaeus maps, each from a different century and a different cultural background, yet all pointing toward the same incredible conclusion. They each contain fragments of a lost world map, a comprehensive chart of the Earth from an era when the coastlines were different, when seas were lower, and when a continent at the bottom of the world was free of its icy shroud. The persistence of this data across centuries and cultures argues strongly against coincidence. It points toward a source, a root from which all these maps ultimately sprang. That source, it seems, was a civilization with the capability and the ambition to map the entire planet, leaving behind a cartographic legacy that would survive its own disappearance, waiting patiently in libraries and archives for a future age to finally understand what it was seeing. So where could such precise and ancient geographical knowledge have possibly originated? The maps themselves, as we have seen, point to a source that predates any known classical civilization by a staggering margin. To make sense of this, we must entertain a truly profound hypothesis: the existence of a sophisticated, seafaring culture that thrived not thousands, but potentially over 100,000 years ago, during the last interglacial period when global climates were warmer and sea levels were significantly higher. This is not a call to blindly believe in the legend of Atlantis, but rather to consider a practical, advanced society that developed the necessary tools for global exploration. Think of them not as gods or mythic figures, but as pragmatic people, skilled navigators, astronomers, and shipwrights who achieved a level of maritime technology that would not be seen again until the great European age of sail. What would such a civilization have required to accomplish this feat? First and foremost, they needed ships capable of withstanding the open ocean for weeks or months at a time. This implies a mastery of woodworking, sail-making, and naval architecture far beyond simple coastal canoes. They would have required a deep understanding of celestial navigation, using the stars to plot courses across featureless waters, which in turn suggests a sophisticated grasp of astronomy and mathematics. Creating an accurate world map from such voyages is another challenge entirely. It requires a conceptual understanding that the Earth is spherical, and the mathematical principles of spherical trigonometry to translate a curved surface onto a flat sheet without gross distortion. This is not primitive knowledge, it is the hallmark of a society with a developed scientific mindset. Their motivation for such ambitious undertakings would likely have been the same drivers behind all great explorations: trade, resource acquisition, territorial expansion, or simply the relentless human curiosity to see what lies beyond the horizon. The most compelling aspect of this theory is how neatly it explains the anomalies we find on the later maps. The precise coastline of an ice-free Antarctica on the Piri Reis Map, the detailed subglacial topography on the Oronteus Finaeus chart, the split continents on the Buache map, these are not random errors. They are consistent, verifiable geographical data. The most logical explanation is that this data comes from a primary source, an original world survey conducted when these landmasses looked very different. This hypothetical civilization would have been mapping the world as it existed during their epoch, a world with coastlines extended by lower sea levels and polar regions free of their current icy caps. Their maps would have been their most valuable assets, carefully guarded knowledge that gave them a supreme advantage in navigation and commerce. Yet, if this civilization was so advanced, why is there no overwhelming archaeological evidence? This is where the concept of a cataclysm becomes essential. The end of an interglacial period is not a gentle transition. It is a dramatic shift into a full-blown ice age, characterized by plummeting temperatures, rapidly expanding glaciers, and a dramatic drop in sea levels as ocean water becomes locked in ice. Alternatively, many ancient cultures speak of a great global flood, which could correspond to the rapid melting of ice sheets at the end of a glacial period, causing sea levels to rise catastrophically and inundating coastal settlements. Either scenario, a devastating ice age or a colossal deluge, would have been apocalyptic for a maritime culture. Their great port cities, built on coastlines that are now underwater, would have been swallowed by the sea or crushed by advancing glaciers. Their infrastructure, their libraries, the vast majority of their material culture would have been obliterated, leaving behind only the most durable fragments. This is where the connection to known ancient seafarers like the Minoans or the Phoenicians becomes so intriguing. These cultures, celebrated in history for their maritime prowess, appear to have emerged with a fully developed understanding of shipbuilding and navigation. What if their knowledge was not entirely original? What if it was, at least in part, a rediscovery or a preservation of a much older legacy? It is conceivable that survivors of the cataclysm, or scattered groups who retained fragments of the ancient knowledge, interacted with emerging cultures. The Minoans, with their sophisticated palaces and vibrant trade networks across the Mediterranean, or the Phoenicians who dared to sail beyond the Pillars of Hercules, may have been the heirs to a cartographic tradition they only partially understood. They would have copied the old maps, using them for their own voyages, preserving the coastlines and landmasses even as the original context for that knowledge faded into myth and legend. These maps, then, became heirlooms of a lost world, passed down through the ages until they finally ended up in the hands of admirals like Piri Reis and scholars like Oronteus Finaeus, who saw the data but could never have guessed its true, ancient origin. But if such a civilization did exist and met a catastrophic end, how could their knowledge have possibly survived the collapse? This is where our search for answers leads us to one of history's most iconic and tragic symbols of lost knowledge, the Great Library of Alexandria. Picture this immense institution not just as a single building, but as the intellectual heart of the ancient world, a university, a research center, and a repository on a scale that is almost unimaginable even today. Founded in the 3rd century before the Common Era, It was a deliberate project by the Ptolemaic rulers of Egypt to gather all the world's knowledge under one roof. It wasn't just Greek scrolls they sought. Agents were sent across the known world to acquire or copy texts from every culture they encountered, from the halls of Babylon to the temples of India, from the trading posts of the Phoenicians to the scholarly circles of Persia. Now consider what might have been housed within its vast collections. It is not only plausible but highly probable that among the hundreds of thousands of scrolls were detailed world maps. These would not have been the simple, symbolic diagrams common in earlier times, but sophisticated charts based on centuries of accumulated exploration. Egyptian pharaohs sent expeditions down the coast of Africa and into the Mediterranean. Babylonian astronomers had mapped the stars with precision. Most intriguingly, the library's own scholars, like Eratosthenes, had calculated the circumference of the Earth with remarkable accuracy and theorized about the existence of unknown continents. It is entirely conceivable that the library's geographers compiled this disparate information into master world maps, synthesizing the reports of Egyptian, Greek, and possibly even more ancient seafaring cultures. These maps would have represented the absolute pinnacle of ancient geographical understanding, potentially incorporating data passed down from a much older, seafaring civilization, the very civilization we have been hypothesizing. The tragic destruction of the library, a slow process of fires and neglect over several centuries, did not mean that every single scroll instantly turned to ash. The common image of a single, catastrophic inferno is a simplification. The loss was gradual, but in that chaos, as scholars fled or as sections of the library were damaged, priceless documents were undoubtedly lost forever. However, the idea that every last piece of knowledge vanished is equally unlikely. Scrolls are portable. Prized texts would have been copied and traded for centuries before the final destruction. Scholars, fearing the loss, would have taken measures to preserve the most valuable works. Fragments of this immense collection would have been smuggled out, sold, or carried to safety by those who understood their worth. These surviving copies became seeds scattered to the winds, taking root in new centers of learning. This is where the historical chain of custody becomes so critical. As the light of classical learning dimmed in Europe during the early Middle Ages, it was the Islamic world that became the primary guardian of ancient knowledge. In cities like Baghdad, Cordoba, and Damascus, caliphs sponsored massive translation projects where teams of scholars worked to translate Greek, Persian, and Indian texts into Arabic. It is along this intellectual Silk Road that we can trace the potential journey of those ancient geographical secrets. A world map from the Library of Alexandria, or a copy of it, could easily have found its way into the hands of an Arab geographer who would have recognized its value, translated its annotations, and preserved its core geographical data. The famous Al-Idrasi map, created for the Norman King Roger Roman II of Sicily in the 12th century, is a stunning example of this synthesis, blending Greek, Arab, and Norman knowledge, and hinting at a level of geographical awareness that seems to exceed contemporary European understanding. Centuries later, as Europe began to reawaken during the Renaissance, the flow of knowledge reversed. Through trade with the Arab world, through the reconquest of Spain, and through the fall of Constantinople, a flood of long-lost classical texts poured back into Europe. Among these returning treasures, it is perfectly logical to suppose were maps that had been preserved in Arabic libraries, now being studied by European scholars with fresh eyes. This provides the missing link, the logical conduit that explains the impossible knowledge on the Piri Reis and Oronteus Finaeus maps. Piri Reis, an Ottoman admiral with access to both European and Arab cartographic traditions, explicitly stated he used ancient source maps. Oronteus Finaeus, a French scholar, would have had access to the rediscovered classical texts circulating in Renaissance Europe. They were not geniuses who independently discovered Antarctica. They were the last recipients in a long, fragile chain of transmission. They were looking at copies of a master chart that once resided in the great Library of Alexandria, a chart that itself was based on the original surveys of a world that no longer existed. The library, therefore, becomes the crucial historical bottleneck, the place where ancient knowledge was concentrated, scattered, and yet miraculously preserved in fragments, offering us a fleeting glimpse of a pre-cataclysmic Earth. While we have been exploring world maps that challenge our entire historical timeline, there is another category of cartographic mystery that is perhaps even more perplexing to mainstream historians because its accuracy is undeniable. Let's shift our focus from the global to the regional, to the Mediterranean Sea, the bustling heart of the medieval world. In the 13th and 14th centuries, a remarkable type of map suddenly appears in European port cities like Genoa and Venice. They are called Portolan charts from the Italian word portolano, meaning a pilot's or sailing guide, and from the moment they appear in the historical record, they are breathtakingly, almost impossibly accurate. The most famous early example is the Carta Pisana, drawn around the end of the 13th century. If you unroll this chart, you are not looking at a speculative or symbolic diagram of the world. You are holding a practical, working tool for navigation, and its precision is stunning. What makes these charts so deeply mysterious is that they seem to have no evolutionary history. In almost every other field of human technology, we see a clear progression. We find crude prototypes, then gradual improvements, and finally a refined final product. But with the Portolan charts, it's as if someone dropped a fully engineered smartphone into the Middle Ages. There are no clumsy, primitive predecessors. The Carta Pisana and its immediate successors, like the Vescont and Medici atlases, display a mastery of coastal cartography that would not be surpassed for hundreds of years. The coastlines of the Mediterranean, the Iberian Peninsula, and the Black Sea are rendered with a degree of detail and proportional accuracy that seems to leapfrog over centuries of technical development. It is an anomaly that defies the standard archaeological model, suggesting that these charts were not invented in the 13th century, but were instead copies, faithful reproductions of a much older, master set of charts whose origins have been completely lost to time. The evidence for this copying theory lies in the chart's construction. The most distinctive feature of a Portolan chart is its web of room lines, those radiating lines that crisscross the map like a spider's web. These were not mere decoration, they were a practical tool. A navigator would draw a line from his starting point to his destination, and then use a compass to sail at the constant angle or bearing indicated by that line. This system worked with remarkable efficiency, but it required an incredibly accurate underlying map to be effective. Even more telling is the chart's astonishing accuracy in terms of latitude. While determining longitude at sea would remain an unsolved problem until the 18th century, these medieval maps show an uncanny understanding of the correct north-south positions of ports and capes. This level of precision implies the original mapmakers had a sophisticated knowledge of astronomy and mathematics that simply was not widespread in medieval Europe. This leads to a radical proposal from some researchers that the original source maps for the Portolan charts were created using the principles of spherical trigonometry. This is the complex branch of mathematics that deals with the relationships between the sides and angles of triangles drawn on a curved surface, which is absolutely essential for creating an accurate map of the Earth. In Europe, the foundational work on spherical trigonometry is attributed to figures like the Persian mathematician al-Battani in the 9th and 10th centuries, and later refined in the West by Regiomontanus in the 15th century. Yet the Portolan charts appear well before this knowledge was common. If the master charts were indeed based on such advanced mathematics, it points to a source civilization that not only understood the Earth was a sphere, but possessed the technical capability to model it with scientific precision. This was knowledge that would be lost, then rediscovered, and its presence on these practical sailing charts hints at a continuous, hidden thread of advanced cartography. The existence of these charts, then, is not just a curious footnote in the history of navigation. They are a silent testament to a tradition of knowledge that operated in the background. While medieval Europe was often fragmented and its geographical knowledge limited, sailors and chart makers in the Mediterranean were using tools of incredible sophistication. This implies a secret lineage, a guild-like tradition where master charts were carefully guarded, copied, and updated over generations, possibly originating from the scholarly work preserved in the Islamic world, or, even more tantalizingly, from ancient Greek or Roman sources that survived the fall of the empire. The Portolan charts are the hard, practical evidence that a detailed and accurate understanding of the Mediterranean world was being preserved and used, even while the official maps of the time showed dragons and mythical kingdoms at the edges of the world. They represent a durable thread of empirical geography, a lifeline of precise coastal knowledge that connected the ancient world to the age of exploration, ensuring that when Europeans finally set sail across the open ocean, they did so with maps that were already far more reliable than anyone could have imagined. Now, let's set our course for the bustling maritime Republic of Venice in the mid-16th century, a time when the city was a hub of trade, intrigue, and cartographic innovation. Here, in 1558, a curious map was published that would fuel debates for centuries. It is known as the Zeno map, and it came with an extraordinary backstory. According to the narrative published alongside it by a descendant, Niccolo Zeno, the map was based on the voyages of his ancestors, two brothers named Niccolo and Antonio Zeno, who had supposedly sailed the North Atlantic nearly 200 years earlier in the 1390s. The map they produced is a fascinating puzzle, a document that blends the seemingly real with the seemingly impossible, creating a snapshot of the Atlantic that is both remarkably insightful and profoundly confusing. What you immediately notice on the Zeno map are the clusters of islands scattered throughout the North Atlantic, each bearing names that stir the imagination. The most prominent of these are Friesland, a sizable island south of Iceland, and Estetiland, which appears to be a vast landmass lying west of Greenland. The problem, of course, is that these places do not exist on any modern chart. Friesland and Estetiland are what cartographers call phantom islands, geographical ghosts that haunted maps for generations. To the skeptical eye, this is enough to dismiss the entire Zeno narrative as a clever hoax or a compilation of sailors' tall tales. But the map is far more complex than that, because nestled among these phantoms are geographical features rendered with surprising accuracy. The map's depiction of Greenland, for instance, is strikingly good for its time, showing a recognizable shape that far exceeds the knowledge generally available in Europe during the 1500s. This strange combination of precision and fantasy is the heart of the Zeno mystery. It forces us to ask a more nuanced question than simply whether the map is true or false. Instead, we must consider what real-world truths might be hidden within its apparent errors. One compelling theory is that these phantom islands are not pure inventions, but rather misplacements or duplications of actual landmasses. Could Friesland, for example, be a distorted representation of the Faroe Islands, or perhaps a misplaced and inflated version of Iceland itself. Sailors' logs from this era were often vague, and distances could be wildly misjudged. A cartographer compiling these reports centuries later might have taken descriptions of the same island from different sources and, not realizing they were the same place, charted them as separate entities. Similarly, Estortilland bears a suggestive resemblance to parts of Newfoundland or Labrador. If the Zeno brothers did indeed reach the coast of North America, as the map hints, their descriptions of this new land could have been misinterpreted by later mapmakers, transforming a coastline into an island or a peninsula. But there is another, even more intriguing possibility that connects the Zeno map directly to our theme of a rewritten world. What if these phantom islands are not misplacements at all, but rather authentic cartographic memories from a time when the world looked very different? During the last glacial maximum, around 20,000 years ago, sea levels were approximately 120 meters lower than they are today. Vast areas of the continental shelf that are now submerged beneath the North Atlantic were dry land. The map we are looking at, then, might not be a chart of the Atlantic as it was in the 1390s, but a faded copy of a much, much older map, one that depicted the Atlantic coastline as it existed thousands of years in the past. Friesland and Estortilland could represent the lingering cartographic echoes of these now drowned lands, plateaus, and islands that were once visible and habitable, but were gradually consumed by the rising seas at the end of the Ice Age. This idea transforms the Zeno map from a simple navigational aid into a potential palimpsest, a document layered with geographical history. The accurate depiction of Greenland represents the contemporary knowledge of the 14th or 16th century, while the Phantom Islands could be stubborn survivors from an ancient source map, copied and recopied for so long that their original context was lost. The mapmaker, whether it was the Zeno brothers or their descendant, would have had no way of knowing that these islands had vanished. They were simply including all the geographical data available to them, blending the modern with the archaic. This would make the Zeno map a cousin to the Portolan charts we discussed earlier, a practical document that also serves as an accidental archive, preserving a glimpse of a landscape that had been rewritten by millennia of climatic change. It stands as a testament to the idea that our maps are not always just guides to the world as it is, but sometimes they are ghostly messages from the world as it was. Up until now, we've explored theories that hinge on lost civilizations and preserved knowledge. But what if the explanation for these cartographic contradictions is even more dramatic? What if the Earth itself physically moved, rearranging the continents in relation to the poles and rewriting the very map of the world within human memory? This brings us to one of the most radical and cataclysmic explanations, the theory of a recent pole shift. It's a concept that suggests the entire outer shell of the planet, the crust, can undergo a rapid displacement, sliding over the molten mantle below like the loose skin of an orange. In such an event, land masses that were once in temperate zones could find themselves at the poles and vice versa, all within a terrifyingly short period. Consider the profound implications of this idea. If the Earth's crust shifted significantly, the geographical poles, the points around which the planet rotates, would appear to move to new locations. This is not the well-understood and very slow continental drift of plate tectonics, which moves continents a few centimeters per year. This is a sudden, catastrophic realignment, a planetary-scale upheaval that would have been the most devastating event in all of human history. The forces involved are almost unimaginable. The spinning planet has immense rotational momentum, and for the crust to shift, it would unleash tsunamis of biblical proportions, hurricanes of unprecedented fury, and earthquakes that would ripple across the entire globe. The very sky would seem to fall as the stars changed their positions. Civilizations, if any survived, would be thrown into a dark age, their world literally turned upside down. Now apply this theory to the enigmatic maps. The most compelling connection lies with Antarctica. On maps like those of Piri Reis and Oronteus Finaeus, Antarctica is depicted with detail that suggests it was mapped when it was free of ice. Mainstream science tells us that for Antarctica to be ice-free, it would have needed to be in a much warmer latitude, as it was millions of years ago. But a pole shift theory offers a different, more recent timeline. What if just 12 or 15,000 years ago, Antarctica was not located at the South Pole at all? What if it was positioned further north, in a temperate climate zone where a civilization could have indeed explored and mapped its green, hospitable coasts? Then a sudden pole shift occurred, sliding the continent to its current, frozen position at the bottom of the world. The maps we are looking at then would not be wrong. They would be perfectly accurate maps of a pre-shift world, surviving relics that show the planet with a different axial alignment. This theory also provides a potential mechanism for the global flood myths that permeate nearly every ancient culture on Earth, from the Mesopotamian epic of Gilgamesh to the biblical story of Noah. A rapid crustal displacement would cause the oceans to literally slosh out of their basins. The centrifugal force of the spinning Earth would drive walls of water across continents, scouring the land and drowning coastal cities. Meanwhile, the new polar regions would experience an instantaneous ice age, as the previously temperate land was plunged into perpetual winter, flash freezing everything in its path. This single event could account for the discovery of mammoths frozen in Siberia with tropical plants in their stomachs, and for evidence of sudden, dramatic climate change found in ice core samples. It's a theory that attempts to tie together a host of geological and mythological anomalies into one grand, terrifying narrative. Of course, it is crucial to acknowledge that this idea is highly controversial within mainstream geology and physics. The established scientific consensus holds that a rapid shift of the entire crust is geophysically implausible. The mantle is not a frictionless surface. The crust is locked to it in a way that makes such a sudden slip incredibly difficult. Critics argue that the forces required, such as a massive impact from an asteroid or a comet, would be so destructive as to likely sterilize the planet entirely, rather than just rearranging the continents. Proponents of the theory, like Charles Hapgood, who was curiously endorsed by Albert Einstein for his open-minded approach, suggested that the buildup of ice caps at the poles could create an imbalance, and once a certain threshold was passed, the weight could cause the crust to shift. But even this mechanism is widely disputed. Whether one finds the pole shift theory compelling or not, its value lies in the perspective it offers. It serves as a powerful thought experiment that challenges us to think about our planet in a more dynamic and unpredictable way. It provides a potential key, a mechanism for unlocking the central mystery of these ancient maps. If the world was indeed rewritten by a cataclysm, then the maps are not errors. They are snapshots of a lost geographical reality. They are evidence of a world that was, before the Great Shift consigned its coastlines to ice and its civilizations to myth. This radical idea pushes the boundaries of the debate, forcing us to consider that the contradictions we see on parchment might not be mistakes of the cartographer, but rather a testament to a planet that is capable of profound and sudden change. Amidst the swirling theories and modern analyses, we must not overlook the most direct evidence we possess, the words of the mapmaker himself. Scattered across the Piri Reis Map are detailed inscriptions, notes written by the admiral in Ottoman Turkish that serve as a kind of cartographer's diary, explaining his methods and his sources. And what he tells us is absolutely crucial. He makes no grand claim of personal discovery or divine inspiration. Instead, with the humility of a scholar, he states plainly that this world map was compiled from approximately 20 different source charts. But he doesn't stop there. He specifies that among these were maps dating back to the time of Alexander the Great, pushing the origin of his data back by nearly 2,000 years from his own time in the 16th century. This is not a vague reference to ancient times. It is a specific historical claim that invites us to consider a lineage of knowledge stretching deep into antiquity. Perhaps the most tantalizing of all his notes is the mention of a map drawn by what he calls the infidel of Ceylon. This single phrase opens up a world of possibilities. Ceylon, modern-day Sri Lanka, was a legendary hub in ancient trade networks, a place where Arab, Indian, Chinese, and Southeast Asian merchants and navigators exchanged goods and undoubtedly information. The term infidel from an Ottoman Muslim like Piri Reis would likely refer to a Hindu or Buddhist scholar from the Indian subcontinent. This points directly to the existence of sophisticated cartographic traditions in the Indian Ocean world that were completely unknown to or ignored by the European West. Imagine the geographical knowledge that might have been accumulated by the great seafaring cultures of southern India or the kingdoms of Sri Lanka, who had been sailing the monsoon winds for millennia. Their maps, if they survived, would have contained a detailed understanding of the Indian Ocean and possibly lands far beyond, knowledge that could have easily found its way into the hands of an Ottoman admiral collecting charts from across the known world. These inscriptions are the bedrock of the entire mystery. They are not the boasts of a man trying to inflate his own importance. They are the meticulous citations of a compiler who is being transparent about his sources. To dismiss the Piri Reis Map as a simple error or a lucky guess, we must also dismiss the admiral's own first-hand testimony. Taking him at his word forces a dramatic reassessment. It means accepting that in the year 1513, a high-ranking Ottoman official had access to a veritable library of ancient maps, a collection of charts that preserved geographical data which flatly contradicted the accepted understanding of the world in his own era. He wasn't drawing fantasy, he was faithfully copying what he believed to be authoritative documents, even if the lands they depicted were absent from all other contemporary maps. This act of preservation is what adds a powerful layer of credibility. Piri Reis was a practical man, a naval commander for whom accurate charts were a matter of life, death, and imperial power. He would have had little patience for mythical lands or pure speculation. The fact that he included this mysterious southern continent, based on these specific ancient sources, suggests he had a high degree of confidence in their reliability. He was effectively making a choice to trust the antiquated data in his possession over the conventional geographical wisdom of his time. This indicates that the maps he was copying from were not seen as obscure curiosities, but as part of a serious, albeit secret, cartographic tradition. Therefore, the inscriptions transform the map from a passive object of analysis into an active piece of testimony. They are the cartographer's own clue, left for us to decipher. They tell us that the mystery is not just about a drawn coastline, but about a chain of transmission. Someone, long before Alexander the Great, mapped the world with astonishing accuracy. That map, or pieces of it, were copied and preserved, perhaps in the Library of Alexandria, perhaps in Indian or Arabian libraries, surviving centuries of turmoil. These copies then fell into the hands of a Turkish admiral who recognized their value and incorporated them into his own work. The Piri Reis Map, therefore, is not the source of the anomaly. It is merely the messenger, and the inscriptions are the message's provenance, a direct link from the 16th century back to a world that had been rewritten, whose true shape was remembered only on a few fragile pieces of parchment. Now, let us turn our attention to another Ottoman cartographer, working just a few decades after Piri Reis, who produced a map containing a different but equally profound geographical secret. In 1559, Haji Ahmed, sometimes known as Hasai Ahmed, crafted a world map that, at first glance, fits the style of its era. Yet, nestled within its depiction of the vast Pacific and the far northern reaches of the world lies a feature that should not have been possible for him to know. He shows a distinct narrow land bridge, a solid connection between the northeastern tip of Asia and the northwestern corner of North America. To a 16th century scholar, this might have seemed a reasonable speculation, a way to connect the known world. But to our modern eyes, this is anything but speculation. It is a precise representation of the Bering Land Bridge, a geological reality that we now know existed for thousands of years but vanished beneath the waves as the last ice age ended. The significance of this cannot be overstated. The Bering Land Bridge, which scientists call Beringia, was not a minor geological feature. It was a vast subcontinent, over 1,000 miles wide at its greatest extent, that emerged as sea levels dropped by hundreds of feet during the glacial periods. This was not a myth. It was a real, habitable landscape of grasslands and rivers that connected Siberia to Alaska. It served as the gateway for the first human migration into the Americas, a journey that began around 16,000 years ago, or perhaps even earlier. Then, as the world warmed and the great ice sheets melted, the seas rose again, and around 11,000 years ago, this entire landmass was submerged, severing the connection between the continents and leaving behind only the Bering Strait. The knowledge of this bridge's existence was lost to all but the indigenous peoples whose ancestors crossed it, their oral histories speaking of a time when the lands were connected. So how did Haji Ahmed, an Ottoman cartographer working in the middle of the 16th century, have any inkling of this long-vanished world? He had no access to deep sea core samples or modern geological surveys. The idea of continental glaciation and sea level change was completely unknown to the science of his day. The most straightforward explanation is also the most staggering. He did not invent this feature. He was copying it from a source. This implies that the source map available to Haji Ahmed was created during a time when the Bering Land Bridge was either still exposed or its existence was a fresh memory. We are not talking about a map from classical antiquity. We are talking about a map of incredible antiquity, one that preserves a snapshot of the world from the end of the last ice age. This pushes the timeline for sophisticated cartography back by millennia. If the Piri Reis and Oronteus Finaeus maps suggest a civilization capable of mapping Antarctica in a warm period, the Haji Ahmed map suggests that the same or a related culture was actively charting the world during or just after the glacial maximum. They were mapping coastlines that are now deep underwater, land connections that have been erased by rising seas. This is not about a single lucky guess or a speculative drawing. It is about a consistent pattern of maps containing data that corresponds to geological epochs, not historical ones. The Haji Ahmed map is a powerful piece of corroborating evidence. It shows that the phenomenon is not isolated to the southern hemisphere. The same pattern of preserved ancient knowledge appears in maps depicting the far north. It paints a picture of a comprehensive global survey, a project to map the entire planet at a time when its geography was fundamentally different from today. Consider the implications for our understanding of human migration itself. The standard model teaches that humans crossed into the Americas via Beringia on foot, but it assumes these were small bands of hunter-gatherers, not advanced cartographers. The existence of a map depicting the land bridge suggests that someone, after the migration, was looking back. it implies a culture with the organization and technological capability to not only traverse this land but to comprehend its strategic importance as a connection between continents and to record it for posterity. This knowledge would have been priceless, the ultimate strategic asset for any seafaring or trading civilization. Its preservation through copies and recopies across thousands of years indicates that this information was considered so vital that it was protected through countless generations, surviving the collapse of the civilization that first created it, only to surface millennia later on a map drawn in the Ottoman Empire, a silent testament to a world that had been rewritten by the rising oceans. Now, to fully appreciate the puzzle these maps present, we must turn our attention to one of the most revered names in the entire history of mapmaking, Gerardus Mercator. In the year 1569, this Flemish cartographer unveiled his revolutionary world map, a masterpiece designed specifically to aid sailors by representing the Earth's spherical surface on a flat sheet with lines of constant bearing, a solution we now call the Mercator projection. His work was the pinnacle of 16th-century scientific cartography, a product of rigorous calculation and a meticulous, scholarly mind. Yet, when we examine this celebrated map closely, we find a fascinating contradiction that lies at the very heart of our mystery. Alongside stunningly accurate depictions of coastlines like that of Greenland, a shape far more correct than on any other map of its time, Mercator included a feature that has no basis in reality. A large, black, magnetic mountain he called the Rupes Nigra, or Black Rock, placed directly at the North Pole. This presents a genuine paradox. How could a man of such scientific rigor, a man who dedicated his life to creating maps of unparalleled navigational utility, simultaneously include a fantastical element straight out of medieval legend? The answer is not that Mercator was being unscientific, but rather that he was operating with a different set of rules for what constituted evidence. He was not just a creator of new geography, he was a compiler of all existing geographical knowledge. His methodology was one of synthesis. He gathered every source he could find: reports from contemporary explorers, charts from Portuguese and Spanish navigators, and crucially, ancient texts and maps from classical and medieval scholars. His genius lay in his ability to weave these disparate threads into a single, coherent tapestry. So, when Mercator came across the legend of the Rupes Nigra, which appeared in various forms on older maps and in travelogues, he faced a dilemma. He had no first-hand accounts from anyone who had actually seen this black rock at the pole. Such a voyage was impossible with the technology of his day. Yet the concept was persistent. It was described as a giant magnetic mountain, 33 miles in circumference, that was the source of the compass's pull and the reason all north-flowing rivers turned in its direction. For Mercator, the sheer consistency of this report across multiple, seemingly independent sources lent it a certain credibility. In his scholarly mind, to omit it would have been to ignore a piece of the geographical puzzle, however strange it might seem. His approach was one of comprehensive faithfulness. He would include all the data from his trusted sources and let future explorers verify or dismiss it. This practice reveals a crucial truth about how these cartographic anomalies survived and were propagated. They were not inserted by fringe eccentrics. They were incorporated by the most respected mainstream authorities of their time. A figure like Mercator acted as a filter, and his filter was set to include, not exclude. If a feature appeared on a source he deemed authoritative, perhaps a map that had also provided him with verifiably correct information about Greenland, he would incorporate that feature into his own work. The anomalous element, like the Rupes Nigra, thus gained a new layer of legitimacy by being printed on a Mercator map. It became woven into the very fabric of accepted geography, its mythical origins slowly obscured by the prestige of the cartographer who included it. The anomaly was sanitized, transformed from a wild sailor's yarn into a documented geographical hypothesis. This process created a kind of palimpsest of knowledge on the printed page. Mercator's map is a snapshot of the 16th century geographical understanding, which was itself a layered accumulation of centuries of information, both empirical and speculative. The accurate coastlines represent the cutting-edge data from the ongoing age of exploration. The mythical elements represent the stubborn survival of much older, unverifiable claims that had been passed down through the chain of copying we've discussed. Mercator, in his desire to be thorough, inadvertently preserved these ancient ghosts. He could not know that the Rups Nigra might have been a symbolic representation of the concept of north, or a misinterpretation of a dark basalt island in the far north like Svalbard. He treated it as a literal place because his sources described it as one. Therefore, the Mercator paradox is not really a paradox at all when we understand the context. It is a testament to the challenge faced by all scholars before the era of instant global communication and satellite verification. How do you separate fact from fiction when your only sources are handwritten accounts and old maps? Mercator's solution was to include everything and let the map be a living document, a work in progress. His inclusion of both the provably accurate and the legendary shows us that the boundary between science and myth was far more porous in his time. It demonstrates that the history of cartography is not a clean, linear progression from error to truth, but a messy, fascinating process of negotiation, where the echoes of a forgotten world could find a safe harbor even in the most scientific of works, surviving long enough for us to rediscover them and ask the questions we are asking today. While our focus has been on the tangible evidence of Antarctica and the North Atlantic, the Pacific Ocean holds its own enigmatic allure, a vast expanse of water that has fueled legends of lost worlds for centuries. Here, the story shifts from ice-covered continents to sunken lands, most famously the hypothetical continent of Mu, sometimes equated with Lemuria. The concept of Mu was popularized in the 19th century by writers like Augustus Le Plongeon, who imagined an advanced Pacific civilization that met a catastrophic end, sinking beneath the waves. Mainstream science and history rightly dismiss Mu as a fiction, a romantic pseudoscience with no geological basis. The Pacific seafloor, formed by tectonic activity, shows no evidence of a recently submerged continent of that scale. Yet, the persistence of the legend, echoed in the folklore of islands from Hawaii to New Zealand, hints at a deeper, more intriguing reality that might be reflected in the cartographic record. This is where we encounter another fascinating category of maps, the deep maps, produced by a school of cartographers in the French port town of Dieppe in the 16th century. These maps are renowned for their detail and artistry. Among them, maps like the Vinland Map feature a massive, intriguing landmass in the southern hemisphere, labeled Java la Grande. This continent appears far larger than the island of Java we know today, stretching along the entire western coast of what we now call Australia. To the European mind of the time, this was the great southern continent, Terra Australis Incognita, a theoretical landmass believed to balance the continents of the north. But what if Java la Grande was not just a theoretical guess? What if it was, like the other anomalies we've studied, a misinterpretation of something real? One compelling interpretation is that Java la Grande represents a distorted memory of the Australian coastline, perhaps based on unrecorded Portuguese or even earlier Chinese voyages that reached its shores before the official Dutch discovery. However, the sheer size and specific shape of the landmass on the deep maps has led some researchers to propose a more radical idea. Could it be a cartographic echo of a time when sea levels were significantly lower? During the last ice age, the continental shelf surrounding Australia was exposed, connecting it to New Guinea and Tasmania in a single landmass known as Sahul. What appears on the deep maps as a vast southern continent might be a fragmented and exaggerated memory of this lost geography, a coastline that was indeed much larger and more complex thousands of years ago, preserved in ancient source maps that were poorly understood by the European copyists. But there is another, perhaps more plausible, explanation that doesn't require a sunken continent. Instead of a literal landmass, these maps could be capturing the ghostly imprint of ancient Pacific exploration. Consider the incredible achievements of the Polynesian voyagers. Using only stars, ocean swells, and the flight paths of birds, they navigated the world's largest ocean, discovering and settling islands from Hawaii to Easter Island to New Zealand in one of the greatest human migrations in history. Their knowledge of the Pacific was vast and sophisticated, passed down through oral tradition and likely through stick charts that mapped currents and islands. It is entirely conceivable that this deep, empirical understanding of the ocean, perhaps encountered by early European explorers who interacted with Polynesian navigators, was misunderstood. A European cartographer, hearing descriptions of a long chain of islands or of a great land to the south, might have consolidated this information into a single, massive continent on his map. Java La Grande might not be Mu, but rather a clumsy European attempt to cartograph the Polynesian mental map of the Pacific world. This idea connects the legend directly to human exploration rather than geological catastrophe. The persistent stories of a lost land across the sea found in so many Pacific cultures may not be about a continent that sank, but about a homeland that was left behind. The voyages of settlement were epic and perilous, and contact with the original islands was often lost. Over generations, the memory of the origin point could have evolved into a myth of a sunken paradise, a place swallowed by the ocean. When European explorers arrived centuries later with their own preconceptions about unknown continents, they may have fused these indigenous legends with their own theoretical geography, creating the phantom continent that appears on the deep maps. The maps, therefore, become a fascinating cultural hybrid, a blend of European speculation and misunderstood indigenous knowledge, keeping the idea of a lost Pacific world alive not as a physical place, but as a powerful testament to the incredible journeys that truly did reshape the human world. Yet amidst the grand theories of pole shifts and lost civilizations, there exists a map that presents a very different kind of mystery, one not of impossible ancient knowledge, but of a potential historical theft. The controversy surrounding the Vinland Map is a modern detective story, a high-stakes battle played out not in archives but in laboratories, and it forces us to confront a fundamental question. Are we looking at one of the most important historical documents ever found, or one of the most ingenious forgeries? The map itself is deceptively simple. It appears as a section of a larger medieval world map depicting Europe, Africa, and Asia. But it is the addition in the Northwest Atlantic that sends shivers down the spine of any historian. A large island labeled Vinlandia Insula, accompanied by an inscription that describes how Leif Erikson discovered this new land. If authentic, this single piece of parchment would be the first known cartographic representation of any part of the Americas, created decades before Christopher Columbus set sail. It would be tangible, incontrovertible proof that the Norse voyages to North America were not just sagas, but documented history that had entered the geographical consciousness of the medieval world. The map's modern history reads like a thriller. It surfaced in 1957, bound within the covers of a medieval manuscript, and was presented to the world with immense excitement by a team of curators from Yale University. The timing was impeccable, coming just as archaeological evidence of a Norse settlement at Elance Ox Meadows in Newfoundland was being uncovered, seemingly corroborating the map's claims. The initial analysis was promising. The parchment was carbon dated to the mid-15th century, and the style of the map's drawing and the Latin inscriptions appeared consistent with the period. For a moment, it seemed that a cornerstone of history had been decisively shifted, granting Leif Erikson his rightful place on the map, quite literally, and rewriting the narrative of the discovery of the New World. However, the euphoria was short-lived. The central pillar of the controversy, and the source of its enduring bitterness, is the ink. When subjected to chemical analysis, researchers made a startling discovery. The black linework of the map was found to contain anatase, a specific crystalline form of titanium dioxide. While anatase can occur naturally, the particular form found on the Vinland Map was of a purity and composition that, according to many scientists, could only be produced by modern industrial processes developed in the 1920s. This was the smoking gun for the prosecution. If the ink was modern, then the map was a forgery, a brilliant but fraudulent creation designed to capitalize on the growing interest in Viking exploration. Proponents of this view argue that a skilled forger acquired a genuine piece of medieval parchment, carefully crafted the map using period-appropriate tools, and then used a cleverly formulated ink to deceive experts, creating a historical sensation and, presumably, a financial windfall. Yet the case is far from closed. A small but vocal group of researchers and historians continues to defend the map's authenticity, and their arguments are not easily dismissed. They point out that anatase has, in fact, been found in a handful of verified medieval manuscripts, suggesting its presence alone is not definitive proof of a modern origin. They argue that the chemical processes within an ink recipe over centuries are poorly understood, and that the anatase could be a degradation product from other, more common medieval ingredients. Furthermore, they highlight the map's profound internal consistency. The depiction of Greenland, for instance, is remarkably accurate for a medieval map, showing a shape that aligns well with reality, and it is drawn as a peninsula, a common misconception in the 15th century before its insular nature was confirmed. A forger, they contend, would have had to possess an incredibly deep and nuanced understanding of 15th century cartographic errors to get such details right, while simultaneously having the chemical genius to create an undetectable fake ink. The debate has become a stalemate, a clash between the seemingly incontrovertible evidence of chemistry and the compelling evidence of historical and artistic consistency. Beyond the scientific and historical arguments, the Vinland Map serves as a powerful cultural Rorschach test. It taps directly into our deep-seated desire to find concrete proof that history is more complex, more interconnected, and more mysterious than the standard textbooks allow. We want to believe that the Norse voyages were not isolated incidents but were known and recorded, that the medieval world was more globally aware than we give it credit for. This powerful yearning can cloud judgment, making us more susceptible to accepting evidence that aligns with our hopes. The map is a perfect symbol of this tension. If it is genuine, it validates a more expansive view of history. If it is a forgery, it is a masterful exploitation of that very desire, a reminder that the line between discovery and deception can be perilously thin. Ultimately, the Vinland Map stands as the ultimate cautionary tale in the world of historical mysteries. It teaches a lesson in rigorous skepticism and the absolute necessity of multidisciplinary verification. It shows that even when a document looks right, and even when its story feels right, we must submit it to the most unforgiving scrutiny that modern science can provide. Yet, its unresolved status also highlights a more subtle truth. The very fact that such an elaborate and sophisticated forgery could be created, if that is what it is, speaks volumes about the cultural power of these cartographic enigmas. The forger, whomever they may be, understood that a map is not just a guide to the world, it is a key to the past. And in creating the Vinland Map, they crafted a key that fits the lock of our imagination perfectly, leaving us forever wondering if it will one day turn and reveal a hidden door, or if it was merely a beautifully crafted replica designed to remind us that the most compelling mysteries are sometimes those we can never fully solve. Now, let us move beyond the coastlines and consider a challenge so fundamental that it plagued cartographers for centuries: the problem of taking the curved surface of our spherical planet and faithfully representing it on a flat sheet of paper. This is the science of map projection, a mathematical puzzle that requires a deep understanding of geometry. The most famous solution, the Mercator projection developed in the 16th century, relies on complex formulas to gradually stretch the landmasses at higher latitudes, allowing a sailor to plot a straight-line course on the map that corresponds to a constant compass bearing on the globe. It was a revolutionary achievement of its time, yet when we examine certain ancient maps, we encounter a baffling reality. Some of these charts appear to possess a level of accuracy, particularly in their longitudinal placement of features, that should have been mathematically impossible for their supposed era. The mystery deepens from a question of what was drawn to the far more profound question of how it was drawn with such precision. The core of this problem lies in the challenge of determining longitude. While figuring out your latitude, your north-south position is relatively straightforward by measuring the angle of the sun or the North Star, pinpointing your east-west position is an entirely different matter. To calculate longitude, you need to know the precise difference in time between your current location and a fixed reference point like Greenwich. For every hour of time difference, you have moved 15 degrees of longitude. This requires an incredibly accurate timekeeping device that can withstand the motion, temperature changes, and humidity of a long sea voyage, a problem that was not solved reliably until the invention of the marine chronometer in the 18th century. Before that, navigators were essentially guessing their east-west position, often with errors of hundreds of miles. This is why early maps frequently have correctly shaped coastlines but place them wildly incorrectly in relation to one another along an east-west axis. This established history makes the precision on maps like the Portolan charts of the Mediterranean all the more astonishing. These are not just roughly correct. Their longitudinal accuracy is far greater than what should have been achievable with the technology available in the 13th or 14th centuries. The coastlines of Spain, Italy, and North Africa are not only recognizable in shape, their relative positions are remarkably true to life. This isn't a mistake that can be explained by lucky guesses or dead reckoning. It suggests the original surveyors possessed a method for determining longitude that has been lost to history. One compelling theory points to the sophisticated use of ancient astronomy. Imagine a network of observatories, perhaps connected to cultures like the Babylonians or the ancient Egyptians, strategically placed across the known world. By carefully observing lunar eclipses or the occultations of stars by the moon, events that are visible at a precise, predictable moment from different locations, these ancient astronomers could have calculated the longitudinal difference between their observatories with a high degree of accuracy. This carefully surveyed geodetic data could then have been used to create a master grid for a world map, a framework of latitude and longitude that was later copied onto navigational charts. Another, even more radical, explanation is that the source maps used by later cartographers were not just ancient, but were based on a comprehensive spherical Earth model from a much older, advanced civilization. This idea separates the act of exploration from the act of cartography. A culture could have had superb ships and skilled navigators who mapped coastlines through painstaking observation. But without a mathematical model, their maps would be a collection of local charts that couldn't be accurately joined together. The leap to a coherent world map requires the conceptual understanding that you are mapping a sphere. The stunning accuracy of some ancient maps implies that this leap had already been made. The original cartographers may have used a projection system similar to what we would later call an azimuthal equidistant projection, where distances from a central point are true, or a stereographic projection which preserves angles. These are complex mathematical concepts. Their apparent use in antiquity elevates the mystery from a collection of curious drawings to a genuine problem of advanced science. We are no longer just looking at maps that show the right places. We are looking at maps that show the right places in the right relationship to each other on a global scale, a feat that demands a sophisticated command of mathematics and geometry. This mathematical component is perhaps the most compelling piece of evidence for a lost epoch of technical achievement. It is one thing for a civilization to build pyramids or chart the stars. These are magnificent accomplishments, but they can be explained through gradual, observable progress. Creating an accurate world map, however, is a synthesis of multiple advanced disciplines: shipbuilding for exploration, astronomy for positioning, and a formalized system of mathematics for projection. It represents a systemic, organized effort to comprehend the entire planet as a single, measurable entity. The presence of this mathematical precision on maps that are merely copies of copies suggests that the root civilization did not just stumble upon geographical knowledge, they systematized it. They possessed a scientific worldview that allowed them to translate the physical reality of a spherical world into an abstract, two-dimensional representation with stunning fidelity. This was not an art, it was a science, and its ghost lingers in the precise angles and proportional relationships of maps that should, by all rights, be riddled with the errors of their time. The lines on the parchment are not just ink, they are the silent equations of a forgotten intelligence. But if the evidence for these maps is so compelling, why is it not taught in every classroom? Why do these mysteries remain on the fringes of mainstream history and archaeology? The answer may have less to do with the maps themselves and more to do with us, with a deeply ingrained human instinct to preserve the stories we think we know. We are storytelling creatures, and we find profound comfort in a coherent narrative. The story of human progress as a linear, upward trajectory from primitive hunter-gatherers to ancient farmers, to classical empires, and finally to our modern technological age, is a powerful and reassuring one. It places us at the pinnacle of achievement, the culmination of millennia of struggle and improvement. To suggest that a sophisticated civilization might have risen and fallen long before the pyramids were even a blueprint is to introduce a jarring, chaotic note into this harmonious symphony. It implies that progress is not guaranteed, that cataclysm can erase even the greatest achievements, and that our own place at the top might be temporary. This is a profoundly unsettling thought, and our first psychological defense is often to reject the evidence that provokes it. This resistance is not merely an emotional reaction. It is structurally embedded within the institutions of knowledge themselves. The entire edifice of modern academia is built upon a specific, carefully constructed chronology. Textbooks are written, careers are built, and reputations are staked on the validity of the established timeline. For a professor who has dedicated their life to studying the rise of civilization in Mesopotamia around 4000 BC, the suggestion that a global maritime culture might have existed 12,000 years ago is not just a new idea, it is a direct challenge to their life's work. It undermines the foundational assumptions of their field. Introducing such a radical paradigm shift would require not just adding a new chapter to history, but effectively ripping up the existing table of contents and starting again. The gravitational pull of the status quo is immense, and the path of least resistance is often to dismiss the anomaly as a hoax, a misinterpretation, or a simple error, thereby preserving the integrity of the entire system. We can see this psychological mechanism at play in the responses to many of the maps we have discussed. The initial reaction to the Piri Reis Map from many established historians was not curiosity, but immediate dismissal. It was labeled a misdrawing of South America, a coincidence, or the result of a lucky guess. The same pattern occurs with the Oronteus Finaeus Map. Its stunning detail is explained away as imaginative cartography, despite its eerie correlations with subglacial topography. This is a classic example of what philosophers of science call paradigm protection. When faced with evidence that contradicts the prevailing model, the initial response is not to question the model, but to find ways to explain away the evidence, no matter how convoluted those explanations may become. It is a form of intellectual gatekeeping, a defense mechanism that protects a community from the cognitive dissonance and professional upheaval that a true paradigm shift would inevitably bring. This is not to suggest a grand conspiracy, but rather a collective, often unconscious bias. Peer review, the cornerstone of academic publishing, naturally favors papers that build upon existing knowledge, not those that seek to tear it down. Grant money flows to projects that operate within accepted frameworks. A young archaeologist proposing to search for the ruins of an unknown, advanced Ice Age civilization would likely find their funding applications rejected and their work marginalized. The system is designed for incremental progress, not revolutionary overhaul. Consequently, the most challenging evidence is often left to dedicated amateurs, independent researchers, and a handful of courageous academics willing to risk their credibility, who then find themselves operating on the outskirts of the mainstream, their work labeled as pseudoscience or fringe history. Understanding this powerful psychological and institutional inertia is crucial. It explains why these cartographic puzzles have not been solved and why they continue to provoke such heated debate. The battle is not just over ink on parchment, it is a battle over the story of humanity itself. Are we the first and only civilization to reach such heights of knowledge, marching steadily upward from the dawn of time? Or are we merely the latest in a long, cyclical series of cultures that rise, flourish, and are inevitably laid low by planetary forces beyond their control? The maps present a vision of history that is far more dramatic, more terrifying, and ultimately more humbling than the one we are comfortable with. They force us to confront our own fragility and the impermanence of our achievements. Accepting their message requires a fundamental shift in our collective identity, a willingness to let go of our cherished narrative of linear progress and embrace a more complex and perhaps more truthful story of rise and fall. Until that psychological barrier is overcome, these silent witnesses from the past will continue to wait patiently in museum vaults and library archives, their secrets intact, challenging a future generation that might finally be ready to listen. To truly understand the weight of these mysterious maps, we need to place them on the grandest stage of all, the centuries-old debate that divides historians into two opposing camps. On one side, you have the diffusionists who see human history as a story of connection, of long-distance travel and cultural exchange across vast oceans, even in the deepest antiquity. On the other, the isolationists who argue that for most of history, civilizations developed in splendid isolation, their achievements springing independently from their own unique environments. This is not a minor academic squabble. It is a fundamental clash of worldviews that dictates how we interpret every ancient artifact, from a similar pyramid design to a shared myth of a flood. And these anomalous maps with their impossible coastlines have become a primary battleground in this intellectual war. For a diffusionist, a map like that of Piri Reis is not an anomaly, it is a smoking gun. It is direct, tangible proof that ancient mariners possessed the skill and courage to sail across the open ocean, carrying their knowledge with them. They point to the Phoenicians, the legendary seafarers from the Levant, who are known to have circumnavigated Africa and may have ventured far into the Atlantic. They point to the Chinese treasure fleets of the 15th century, which were larger than any European ships of the era, and whose full range of exploration remains unknown. Or they propose the existence of a completely unknown culture, a maritime civilization that served as a global conduit, sharing cartographic secrets that later filtered down to the Egyptians, the Minoans, and beyond. In this view, the accurate depiction of Antarctica is not a mystery. It is simply a piece of geographical data that was gathered by an intrepid explorer and then passed along a complex intercontinental trade route, a secret held by guilds of sailors for generations. The isolationist perspective offers a much more conservative, and to many, a more scientifically rigorous explanation. They argue that the human mind is a pattern-seeking engine, and that cartographers, like all artists, worked with the limited information they had. The strange landmass on the Piri Reis map is not Antarctica. It is a distorted, poorly understood rendering of the southern tip of South America, blended with speculative geography to fill the empty spaces on the page. The correlations with subglacial topography, sheer coincidence amplified by researchers who are seeing what they want to see. For the isolationist, these maps are fascinating historical documents, but they are compilations of myths, sailors' tall tales, educated guesses, and honest errors in copying over centuries. There were no pre-Columbian voyages to Antarctica, no global networks. Instead, similar ideas arose independently because humans, faced with similar problems, often arrive at similar solutions. This debate becomes intensely personal when we consider the achievements of indigenous cultures. The isolationist view rightly seeks to honor the independent genius of civilizations like the Maya or the ancient Egyptians, arguing that they developed writing, astronomy, and monumental architecture on their own without needing outside inspiration. To suggest that their accomplishments were sparked by contact with foreign visitors can, in its most problematic form, diminish their own ingenuity. The diffusionist argument, however, counters that celebrating connection does not negate local genius. It simply acknowledges that humans have always been curious, mobile, and eager to exchange ideas. They argue that the isolationist model, in its zeal to protect cultural sovereignty, might be ignoring a richer, more interconnected human story. What makes these ancient maps so powerful is that they force us to move beyond abstract theory and confront a physical object. You can hold a photograph of the Piri Reis map in your hand. You can see the coastline. It is a data point that refuses to be easily dismissed by either side. For the diffusionist, it is irrefutable evidence. For the isolationist, it is the ultimate test of their skepticism, requiring a complex explanation for why it looks so right. The maps, therefore, act as a litmus test for our own preconceptions about the past. Do you look at human history and see a series of separate, isolated experiments, each a brilliant but independent flame? Or do you see a single, interconnected narrative, a web of connections with many lost chapters, where a map could travel from one side of the world to the other, carrying the secrets of a forgotten age? The ink on these ancient charts forces us to choose, and in doing so, reveals not just the secrets of the past, but the biases we bring to its interpretation. While the theory of a pole shift offers a dramatic, almost cinematic explanation for our anomalous maps, there exists a far more gradual and scientifically undeniable force that has relentlessly reshaped our world: the slow, powerful rhythm of changing sea levels. To understand this, we need to reimagine the planet not as a static globe, but as a dynamic system breathing in and out over vast stretches of time. During the peak of the last ice age, around 20,000 years ago, the Earth was in a deep freeze. So much of the planet's water was locked up in colossal ice sheets, miles thick, covering much of North America and Northern Europe, that the global sea level was about 120 meters lower than it is today. That's the height of a 40-story building. This wasn't a minor adjustment. It was a radical reconfiguration of the world's geography. The effect on the coastlines was nothing short of spectacular. What are now continental shelves submerged under shallow seas were vast, exposed plains. Imagine a world where you could walk from France to England without getting your feet wet across the sprawling expanse of Doggerland. Picture a continuous land bridge, Beringia, connecting Asia to North America, not as a narrow strip but as a subcontinent teeming with life over 1,000 miles wide. The Indonesian archipelago and the islands of Southeast Asia were not islands at all, but part of a gigantic peninsula called Sundaland, which extended the Asian continent far out into what is now the Java Sea and the South China Sea. Australia was fused with New Guinea and Tasmania into a single massive continent known as Sahul. This was the Earth during the Ice Age, a planet with more land, different rivers, and coastlines that would be utterly unrecognizable to us today. Now, let's apply this geological reality to our cartographic mystery. What if the source maps used by Piri Reis, Oronteus Finaeus, and others were not based on surveys from their own time, or even from classical antiquity, but were instead copied from surveys conducted during this Ice Age epoch? A map created 20,000 years ago would naturally depict the world as it was then. It would show the extended coastline of Sundaland, the dry basin of the Persian Gulf, the sprawling plains of Doggerland. To a cartographer in the 15th or 16th century, unrolling this ancient chart, these landmasses would be baffling. They wouldn't match the world as they knew it. The coastlines would appear to be in the wrong place. The shapes of continents would seem distorted. They might interpret these features as errors, or they might faithfully copy them, not realizing they were looking at a snapshot of a lost world. This offers a powerful and elegant solution to the puzzle. The anomalies on these maps may not be mistakes at all. They could be accurate representations of a geography that simply no longer exists. Take, for example, the depiction of islands or landforms in the North Atlantic on maps like the Zeno chart. While some may be misplacements, others could be the cartographic ghosts of now submerged peaks or plateaus that were once above water. A coastline that seems too far east or west on an ancient map might be perfectly correct if you account for the fact that the entire shoreline was many miles further out to sea when the map was originally drawn. This transforms the mystery from a question of impossible knowledge to a question of misunderstood chronology. The cartographers weren't wrong. They were just working from a map that was made for a different version of Earth. The great advantage of the sea level change hypothesis is that it is grounded in solid, mainstream science. While a rapid pole shift remains a controversial and unproven theory, The fluctuation of sea levels during glacial and interglacial cycles is an established fact, documented in ice cores, sediment layers, and fossil records. It provides a gradual, natural mechanism for how the world can be rewritten without requiring a planetary catastrophe. The process is slow, taking thousands of years, but its cumulative effect is total. It doesn't erase civilizations with a single cataclysm, but it does steadily drown their world, inch by inch, century by century, forcing coastal populations to retreat and eventually forgetting the lands they left behind. This perspective allows us to view these ancient maps in a new light. They are not necessarily relics of a single, advanced civilization that mapped the entire globe in a golden age. Instead, they could be palimpsests of geographical memory, preserving data from many different eras. A single map might be a composite, with some coastlines reflecting knowledge from the Ice Age, while others show updates from the Classical period, and still others include the speculative additions of medieval copyists. The accurate parts are the ones that were faithfully transmitted from a time when that geography was real. This makes the maps even more fascinating. They are not a single photograph of a lost world, but a collage, a layered document showing the Earth as it was across millennia. The coastlines have changed, but on these fragile pieces of parchment, the ghost of the old shoreline remains, a silent testament to a world that vanished beneath the waves. But what if the most celebrated explorers of the Age of Exploration were not setting sail into a complete unknown? What if, tucked away in their cabins, they carried not just courage and ambition, but secret charts, fragments of maps hinting at lands beyond the horizon? This possibility reframes the entire era from a story of fearless pioneers discovering a new world to one of determined adventurers following the faded trails of a much older one. Consider Christopher Columbus, a figure shrouded in as much mystery as the seas he crossed. We know he was an avid student of geography, poring over classical texts like the works of Ptolemy and the travels of Marco Polo. But his own writings and logs suggest he had access to something more, something tantalizingly specific. He famously argued that the Earth was smaller than most scholars believed and that Asia could be reached by sailing west. While this is often presented as a brilliant miscalculation, what if it was a calculated inference based on maps he had seen? There are persistent accounts, though difficult to verify, that Columbus had obtained a chart from a mysterious, drowned sailor that showed islands in the western Atlantic. He wasn't just guessing, he was operating on intelligence. This idea transforms the nature of his legendary voyage from a desperate gamble into a targeted mission. When his crew grew mutinous after weeks at sea, Columbus reportedly used his secret knowledge to bolster their morale, privately assuring his captains that land was near. His famous sighting of land on October 12, 1492, was not a lucky break but the confirmation of a route he believed existed. If true, then the discovery of the Americas was less of a discovery and more of a rediscovery. Columbus wasn't finding a new world. He was arriving at a destination that had been mapped long before, guided by the cartographic ghosts of a forgotten age. He was the culmination of a chain of knowledge, a man with the will and the means to act on ancient information that had been preserved in Portuguese and Spanish libraries, perhaps originating from the same stream of lost cartography that informed Piri Reis. This pattern extends beyond Columbus. Ferdinand Magellan, who set out to find a western route to the Spice Islands a generation later, possessed a deep conviction that a strait existed through the southern tip of South America. His relentless search for the passage that now bears his name seems less like blind faith when you consider the maps available at the time. The Waldseemüller map of 1507, for instance, already hinted at a vast ocean beyond the Americas, which he labeled Mare Pacificum. Where did this knowledge come from? It's possible that scattered reports from unrecorded voyages, or again, fragments of much older source maps, had given European cartographers a hazy but accurate picture of the world's general layout. Magellan's voyage, then, was not about proving the Earth was round. Educated people already knew that, but about verifying and exploiting a geographical hypothesis that was already in circulation among the maritime elite. This perspective dramatically alters the narrative of the age of exploration. It suggests that the great surge of European voyages was not a sudden explosion of ingenuity, but a systematic effort to recover and confirm lost knowledge. The explorers were the field agents of a geographical revolution that was already underway in the map rooms of Lisbon, Seville, and Genoa. They were sent to fill in the blanks on charts that already contained the rough outlines of continents. This doesn't diminish their incredible courage or seamanship. Navigating the Atlantic and Pacific with 16th-century technology was a harrowing feat, regardless of what maps they had. But it does add a profound layer of intrigue. It means that the unknown worlds they encountered were only unknown to them. Someone else had been there first, someone with the skill to chart the coasts and the means to preserve that knowledge through cataclysms and dark ages, only for it to resurface at the dawn of a new era of global ambition. The age of exploration becomes a chapter in a much longer story, a period of reconnection with a planet whose true geography had been remembered only in whispers on parchment. For centuries, the debate over these enigmatic maps was confined to the dusty corners of libraries and the passionate arguments of a few dedicated researchers. It was a battle of interpretations, of comparing one faded piece of parchment to another, with no way to definitively prove or disprove the astonishing claims being made. But then, something extraordinary happened. We left the Earth. The dawn of the space age and the digital revolution gifted us with a set of tools that previous generations could only dream of, the ability to see our planet with godlike clarity and precision. We developed technologies that could peer through miles of Antarctic ice, map the deepest ocean trenches, and create a digital, three-dimensional model of the entire globe. Suddenly, the speculation could be tested. The claims of ancient mapmakers could be held up against the irrefutable data of modern science. This verification process begins with one of the most powerful instruments ever pointed at Antarctica: ice-penetrating radar. Mounted on aircraft and satellites, these systems don't photograph the surface. They send down pulses of energy that travel through the ice sheet, reflecting off the bedrock below. Layer by layer, these echoes are compiled by powerful computers to create a detailed topographic map of the continent's true skeleton, the landscape that has been hidden from direct view for millions of years. The result is a chart of stunning detail, showing mountain ranges, vast valleys, and deep basins, the actual shape of Antarctica, stripped of its icy cloak. It is this modern benchmark, this objective truth of the subglacial world, that researchers use as their Rosetta Stone to decipher the ancient maps. The moment of comparison is where the mystery either collapses or deepens into something far more profound. When historians like Charles Hapgood first overlaid the Oronteus Finaeus map from 1531 with preliminary seismic data in the 1960s, the correlations were startling. The map's depiction of a central depression aligned almost perfectly with the location of the vast subglacial basins under East Antarctica. The river-like features flowing from the interior matched the courses of known subglacial waterways. The overall shape of the coastline, while not a perfect match, showed a resemblance that seemed to go far beyond random chance. Similarly, the split continent depiction on the Buache map finds a curious echo in the modern understanding that Antarctica is essentially a massive archipelago of landmasses, primarily East and West Antarctica, separated by the deep trough that underlies the transantarctic mountains. Of course, the process is not without its fierce critics. Skeptics rightly point out that any comparison between a hand-drawn, centuries-old map and a precise satellite survey requires a degree of interpretation. They argue that with enough flexibility, you can make almost any two shapes appear to correlate. They note that the Piri Reis Map is just a fragment, making a conclusive overlay difficult, and that some of the apparent matches might be the result of the cartographer's own guesswork or the distortion inherent in old projection methods. This scientific skepticism is healthy and necessary. It forces proponents of the ancient civilization theory to refine their arguments and seek ever more rigorous comparisons. The debate now often revolves around statistical probability. Just how likely is it that a 16th century mapmaker could have guessed the subglacial topography with the accuracy we see? Yet, despite the debates, the simple fact that we can have this discussion on such a technical level is a victory for the mystery. We have moved from asking, "Could this be possible?" to arguing over the specifics of geological correlation. This modern verification process acts as a crucial bridge, connecting the intuitive, almost artistic knowledge of the ancients with the hard, empirical data of contemporary science. It provides a common ground, a shared set of facts that both skeptics and believers must acknowledge. The satellite maps don't automatically prove the existence of Atlantis, but they do confirm that the old maps contain information that is inexplicable within the standard historical model. They show us that the cartographers were not just drawing myths, they were reproducing specific geographical data, and that data corresponds to a reality we can now measure independently. This technological lens allows us to see these ancient documents not as curiosities, but as potential data sets waiting for the right key to unlock their secrets. Perhaps the truth behind these enigmatic maps lies not in a library of forgotten science, but in the living memory of humanity itself. Consider a different lens through which to view the mystery, the cultural memory hypothesis. This idea proposes that these charts are not direct copies of precise, ancient surveys, but rather a fascinating fusion of empirical observation and deep-seated mythological memory. Every culture around the world, from the Mesopotamians to the Maya, possesses a foundational myth of a great flood, a cataclysm that reshaped the world and drowned ancient homelands. What if cartographers, acting as the intellectuals of their age, heard these persistent legends from sailors, traders, and storytellers, and made a conscious decision to incorporate them into their geographical models? They weren't necessarily working from a technical blueprint of a lost continent, but were attempting to give physical form to the haunting stories that echoed across generations. A perfect example of this process is the phantom island of High Brassil, which appeared on nautical charts off the coast of Ireland for hundreds of years. It was typically shown as a circular island, often split by a central river. In Irish myth, High Brassil was a mystical, fog-shrouded land of eternal youth, a paradise that appeared only once every 7 years. There is no physical island there, and yet for centuries experienced mariners and respected mapmakers insisted on its existence. It's highly unlikely they were all conspiring to create a hoax. A more plausible explanation is that the powerful Celtic myth was so ingrained in the seafaring culture of the North Atlantic that it transcended folklore and became accepted geographical fact. The cartographers weren't lying. They were documenting a cultural reality, translating a profound story from the collective unconscious into a tangible location on parchment. This transforms our understanding of the maps from simple navigational aids into cultural palimpsests. A palimpsest was a medieval manuscript where old text was scraped away to make room for new writing, but faint traces of the original would often remain visible beneath the surface. Think of these anomalous maps in the same way. The top layer, the most visible ink, represents the accurate, verifiable geography of the cartographer's own time, the correctly rendered coastlines of Europe, the known islands of the Mediterranean. But layered underneath, like ghostly script, are the geographical memories of a much older world. These are not precise surveys, but rather the distorted, mythologized echoes of real events. The memory of the vast, fertile plains of Doggerland before it was swallowed by the North Sea, or the oral histories of a time when the Sunda Shelf was a sprawling peninsula, not a submerged archipelago. This hypothesis offers a compelling middle ground in the fierce debate between the diffusionists and the isolationists. It doesn't require us to believe in a single, technologically advanced global civilization, nor does it force us to dismiss the maps as mere coincidence or error. Instead, it presents a more human, more psychologically resonant explanation. It suggests that the mapmakers were synthesizers, weaving together every thread of information available to them: the hard data from contemporary explorers, the fragments of classical geography they had rediscovered, and the powerful, pervasive myths that formed the bedrock of their cultural identity. Their goal was not just to chart the sea, but to create a complete picture of the world, one that made sense of both physical reality and the stories that gave their world meaning. The result is a composite image, a beautiful and confusing blend of science and legend, where the outline of a very real Antarctica might be fused with the mythological memory of a lost golden age, creating a document that is as much a map of the human psyche as it is a map of the Earth. The pursuit of these cartographic secrets, however, is not a path walked only by earnest scholars. It is a field shadowed by the deliberate and often brilliant work of deceivers. The unfortunate reality is that the allure of a rewritten history is so powerful that it has inspired not just research, but also forgery. These hoaxes, crafted with painstaking care, present a profound ethical dilemma, muddying the waters for everyone and forcing a level of skepticism that can sometimes border on cynicism. The most infamous case, as we've touched upon, is the Vinland Map, but it is far from alone. Throughout history, individuals have created fake maps for a variety of motives: the desire for fame and recognition, the lure of significant financial profit from selling a lost treasure to a collector or institution, or even to advance a specific ideological or nationalist agenda to prove that one's own culture was first to discover a land. The damage caused by a successful forgery is immense and far-reaching. When a map like the Vinland Map is initially accepted by credible institutions, only to be later challenged by forensic science, the resulting scandal doesn't just discredit that single document. It casts a long shadow of doubt over every other genuine anomaly. Skeptics gain a powerful weapon, a ready-made example to dismiss any challenging discovery as probably another hoax. This forces legitimate researchers into a defensive posture. They must now spend invaluable time and resources preemptively proving the authenticity of their subject, employing tools like carbon dating, ink analysis, and vellum sourcing, not just to understand the map's origin, but to defend its very legitimacy against the suspicion sown by the forger's art. This hypervigilance can slow progress to a crawl and make it difficult to get serious academic attention for truly puzzling artifacts, as the fear of being associated with a fraud becomes a significant barrier. Yet, if we step back, the very existence of these forgeries tells us something incredibly important about the human psyche. A forger does not invest enormous effort into creating a convincing fake of something nobody cares about. The act of forging a map that shows pre-Columbian contact with the Americas, or an ice-free Antarctica is in itself a backhanded compliment to the power of these ideas. The forger is betting correctly that there is a deep and widespread public fascination with the concept of a hidden past. They are exploiting an intuition that many people share, a feeling that the official story is incomplete, that there are lost chapters in the human saga. In a strange way, the creation of a forgery is an admission that the idea of a rewritten history is potent, compelling, and marketable. It demonstrates that the question, "What if?" holds a powerful grip on our imagination. This creates a fascinating paradox. The same public thirst for mystery that drives legitimate research also creates the market that makes forgery profitable. We, the audience, are complicit in this cycle. Our desire for tangible proof, for a smoking gun that overturns the history books, makes us vulnerable to deception. A well-crafted forgery gives us exactly what we want, a simple, elegant, and dramatic answer. It can be more satisfying in the short term than the complex, ambiguous, and often frustratingly incomplete evidence offered by genuine anomalies. The forger preys on this desire for clarity, offering a seductive but false resolution to the mystery. Therefore, navigating this landscape requires a balanced approach. We must cultivate a healthy skepticism, embracing the rigorous scientific methods that can expose a fake. But we must not let that skepticism harden into a closed-minded dismissal of all evidence that challenges the mainstream narrative. The presence of counterfeit bills doesn't mean all money is fake. It just means we need to be better at spotting the real thing. The ethical duty falls on both researchers and the public. Researchers must be transparent about their methods and welcome scrutiny, while we, as consumers of this history, must learn to appreciate the slow, meticulous process of investigation over the allure of a dramatic but unverified claim. The forger's shadow, while problematic, ultimately highlights the immense value and significance of the genuine search. It reminds us that the truth about our past is a prize worth protecting, precisely because it holds such profound power to reshape our understanding of who we are. So where does all of this leave us? We have a collection of maps from different centuries and cultures, each containing fragments of geographical knowledge that seem to defy the timeline of history as we know it. The temptation is to latch onto a single, dramatic explanation, a lost Atlantis, a sudden pole shift, but the truth is likely far more complex and nuanced. The most compelling narrative, the one that best accounts for all the evidence, is not a single theory but a grand synthesis, a tapestry woven from several distinct threads. It's a story that combines a prehistoric achievement, a tragic loss, a long preservation, and a world that was physically transformed. Let's begin with the source of the knowledge. The astonishing precision of the coastlines, particularly the subglacial topography of Antarctica, points overwhelmingly to a primary survey. This wasn't guesswork or myth. It was the result of actual exploration and measurement. The most logical conclusion is that a sophisticated maritime culture, whose name is lost to time, existed in deep antiquity. This civilization possessed the shipbuilding technology for transoceanic voyages and, crucially, the mathematical understanding for advanced cartography, allowing them to create a spherical model of the Earth. They likely thrived during a warm interglacial period, a time when the Antarctic coastline was accessible and free of ice, and when sea levels were different, exposing land bridges like Bering. They weren't mapping a mythical world, they were mapping their world, a planet with a geography subtly but significantly different from our own. This leads to the second thread, the mechanism of preservation. A civilization, no matter how advanced, is fragile if its knowledge is concentrated in one place. The Great Library of Alexandria provides the perfect historical bottleneck for this narrative. It's entirely plausible that the master world maps from this lost civilization, or copies of them, found their way into the library's vast collection, where they were studied by Greek and Egyptian scholars who may have incorporated this ancient data into their own geographical works. When the library suffered its slow and tragic destruction, this knowledge didn't vanish entirely. Fragments were saved, copied, and carried to new centers of learning in the Byzantine Empire and the Islamic world. Arab scholars, becoming the new guardians of classical knowledge, preserved and translated these texts, which included the strange and unverifiable coastlines from the ancient maps. Centuries later, through trade and the reconquest of Spain, these documents filtered back into Renaissance Europe, where scholars like Oronteus Finaeus and cartographers like Piri Reis encountered them. They, in their turn, faithfully copied what they saw, even though the lands depicted contradicted the known world of their day. This gives us a credible, historical pathway for how such ancient knowledge could survive for millennia, passed down like a whispered secret through a chain of scholars and libraries. Then we have the third element, the changing world. Why do these old maps seem so wrong to us? Because the planet itself has been rewritten. The well-documented rise in sea levels since the end of the last ice age has dramatically altered coastlines, drowning continental shelves and turning land bridges into straits. A map made 15,000 years ago would naturally show a world we barely recognize. Furthermore, the possibility of a minor crustal displacement, a small shift in the Earth's poles, cannot be entirely ruled out as a contributing factor. Such an event, even if not as catastrophic as a full pole shift, could have slightly repositioned continents, making the old maps appear rotated or misplaced. This combination of rising waters and a potential shift in alignment elegantly explains the apparent errors. The maps aren't erroneous, they are simply outdated, reflecting a geographical reality that has since been erased and overwritten by natural planetary processes. When we braid these three threads together, the ancient source, the library transmission, and the altered world, we arrive at a narrative that is both staggering and strangely coherent. It accounts for the precision we see on the Piri Reis and Oronteus Finaeus maps. They are echoes of a real survey. It explains how the knowledge survived through the great libraries and the scholarly traditions that preserved ancient texts. And it resolves the contradictions. The maps seem wrong because the Earth itself has changed. This synthesized story doesn't require a single cataclysm to explain everything, but rather a series of interconnected events spanning thousands of years. It suggests that human history is not a simple line but a complex web, with cycles of discovery, loss, and rediscovery. The enigmatic maps are the tangible proof of this deeper, richer, and more mysterious past, inviting us to see our own place in history not as a pinnacle, but as a chapter in a much longer and more incredible story. Accepting the evidence presented by these maps requires us to dismantle one of the most foundational narratives of our modern world, the story of linear progress. From the moment we are children, we are taught a history that moves in a single, upward direction. It begins with primitive hunter-gatherers, advances to the first farmers, ascends to the glory of classical empires, dips into a dark age, and then steadily climbs through the Renaissance and the Enlightenment to arrive at our current technological pinnacle. We are the culmination, the end product of this long, unbroken march forward. But what if this story is not just incomplete but fundamentally wrong? The existence of precise geographical knowledge from a time before recorded history suggests a different, far more dramatic pattern, a cyclical view of civilization. In this cyclical model, human achievement is not a steady climb but a series of great waves. A civilization rises, perhaps from humble beginnings, and through a combination of ingenuity, resourcefulness, and favorable conditions, it ascends to a peak of technological and cultural sophistication. It develops advanced mathematics, masters materials science, and explores its world with a confidence we would recognize today. This is the age of mapping, of global exploration, of building and creating. But then the wave inevitably crashes. The cause could be external, a rapid shift in climate, a volcanic super-eruption, an asteroid impact, or the slow, inexorable creep of glaciers or rising seas. Or it could be internal, the overconsumption of resources, a devastating war, or a social collapse that unravels the fabric of their society. The result is the same, a cataclysm, a great forgetting. The libraries burn, the cities are abandoned, the specialized knowledge is lost, and the survivors are thrown back into a struggle for basic survival. The great edifice of their civilization is reduced to rubble, and then to dust, and finally to legend. This perspective is profoundly humbling. It suggests that our own technological age, with its satellites and smartphones and global networks, is not a unique, unprecedented event in human history. We may simply be the latest civilization to reach this particular point on the cycle. The achievements we consider uniquely ours: global communication, precise navigation, the mapping of the entire planet, may have been accomplished before, perhaps multiple times, only to be swept away. This doesn't diminish our accomplishments, but it does place them in a much broader context. We are not the first to gaze at the stars and calculate our place in the cosmos. We are simply the most recent to have the luxury of doing so. This realization carries a sobering responsibility. If civilizations have fallen before, what makes us think we are immune? The cyclical model forces us to confront our own vulnerability, to see the potential cracks in our own foundation. Yet this view is also strangely inspiring. It speaks to an incredible resilience inherent in humanity. After each collapse, after the darkness descends, the seeds of knowledge are not completely extinguished. They survive in the most tenacious ways. A handful of survivors might preserve crucial skills, metalworking, agriculture, or the principles of navigation, passing them down orally through generations. A precious library might be partially saved, its scrolls copied and hidden away in a monastery, or carried across deserts by scholars fleeing the chaos. The maps we have been discussing are the ultimate testament to this survival. They are the seeds. A complex understanding of spherical trigonometry and global geography was not reinvented from scratch in the Renaissance, it was rediscovered. It had been preserved like a dormant seed in those ancient source maps, waiting for the conditions to be right for it to sprout again in the minds of a new age. The work of figures like Mercator and Oronteus Finaeus was not pure invention, it was an act of revival. This changes how we view historical periods we once labeled as dark ages. Rather than being eras of pure ignorance, they might be better understood as periods of consolidation and preservation. While the grand architecture and centralized power of a previous age crumbled, the essential knowledge retreated to smaller, more resilient communities. It was refined, simplified, and kept alive until the world was stable enough to support a new flowering. The cycle is not just one of destruction and loss, it is also a cycle of preservation and rebirth. The human drive to understand and to explore is so powerful that even a cataclysm cannot erase it completely. It may force it underground for centuries, but it will eventually re-emerge, pushing a new civilization to map the same coasts, to chart the same stars, and to once again ask the great questions about the world and our place within it. We are not just repeating mistakes, we are also rediscovering truths, generation after generation, wave after wave. These maps we have explored, from the fragment of Piri Reis to the stunning detail of Oronteus Finaeus, are far more than just parchment and ink. They are silent witnesses, stubborn survivors from a time we have forgotten. They do not shout their secrets, they whisper them in the lines of coastlines that should not exist and the annotations that speak of lands beyond all contemporary knowledge. What they suggest is nothing short of revolutionary, that the human story, as we have been taught it, is incomplete. Our past appears to be deeper, richer, and infinitely more mysterious than any textbook would dare to admit. We are left with a profound sense that the timeline of civilization is not a simple, upward-sloping line, but a complex tapestry with entire chapters missing, perhaps lost to some great cataclysm or simply worn away by the slow passage of millennia. While a single, undeniable piece of proof, a sunken city in the right location, an artifact with a matching inscription may remain elusive, we must not underestimate the power of cumulative evidence. Think of it as a court case built on circumstantial evidence. One strange map could be a coincidence, two could be a curious anomaly, but when we have a dozen from different cultures and different centuries, all pointing toward the same impossible conclusion, the case becomes compelling. The consistent depiction of an ice-free Antarctica, the accurate subglacial topography, the memory of the Bering Land Bridge, these are not random errors. They form a pattern, a coherent signal emerging from the historical noise. This collective weight challenges us to reconsider not just what we know, but how we know it, forcing a humility about the limits of our own understanding. Perhaps, then, the ultimate value of this entire investigation is not in arriving at a final, definitive answer. The true gift of these maps is the journey of questioning they inspire. They re-enchant the world, inviting us to look at a simple coastline and wonder not just where it leads, but when it was first charted, and by whom. They encourage a sense of wonder, a feeling that our planet still holds profound secrets, and that history is not a closed book but an ongoing detective story. The search for truth, with all its dead ends and tantalizing clues, is often more rewarding than any single conclusion could ever be. It is the quest itself that expands our minds and keeps the flame of curiosity burning brightly. So what other traces of a rewritten world are still waiting to be discovered? They might be hidden in plain sight, encoded in other ancient texts, or buried in the oral traditions of indigenous cultures. They could lie at the bottom of the sea, on the now submerged continental shelves that were once dry land, holding the ruins of coastal settlements from a forgotten age. The next great discovery might not be a map, but something even more tangible, something that connects these cartographic ghosts to a physical reality. The mystery is far from over. In many ways, it has only just begun. We would love to hear your thoughts on these enigmatic documents. Which map do you find the most compelling? What theory about their origin resonates with you? Share your ideas in the comments below. And if you enjoyed this journey to the edges of known history, please subscribe for more explorations into the world's greatest mysteries.